So we're going to work out the determinant of a matrix, either a 2 by 2 or a 3 by 3. Okay, so it has to be a square matrix. Now basically the determinant is only really used to figure out the inverse of a matrix, right? But there is something really, really important, which is this. So a matrix is singular if the determinant is 0. So if you did that and you got your determinant as being 0, it basically means there's no inverse. Okay, which is very, very important. So that's the whole point of the determinant. Basically, it tells you if there is an inverse of it. The number's kind of irrelevant in a sense. Right, so for a 2 by 2, the determinant is this. So what it means is AD, take away that times that. And this is not on your formula sheet, but it kind of ties in with the 3 by 3 anyway. So basically, determinant of A is those two. Take away those two. Which is obviously 8. Take away -3, which gives you 11. Nice and easy. So that means this one does have a matrix. does have an inverse. And you can use the determinant when you're getting the inverse later on today. Right, a 3 by 3, however. So a 3 by 3 is more complicated. Now this here, okay, is on your formula sheet. It's called the cross product. And we normally use it in vectors, we're not doing vectors. Now, it talks about here we gave a table of signs. Now, basically, we just focus in on this bit here. As again, as I talk through it with you, you'll see what I mean. So, it's on your formula sheet. And you can see it's kind of like this wee bit here. It's kind of like the 2 by 2 anyway. Right, how do we do this? So, first thing we want to do is we set up, so ask you for the determinant. And I said earlier, what they could do is they could ask the determinant like this. They could use square brackets to show it's the determinant. So the determinant of A is, right, what we do is we take our first row and they're going to go in front of, so we do 3, and then basically we're getting determinant of 2 by 2s. Now, we're going to rub this out as I go, but that 3, if you imagine like getting rid of that row and getting rid of that row, the 3's in, this row in the column, you're left with that 1, -2, 1, 1. Okay? Then we do the same with the 1. Now the difference with this is this kind of table of signs. It goes plus, minus, plus. So we've got next is a minus. Then we're looking at the next number in the top row, which is 1. And again, you're imagining, right, if I get rid of the row in the column that 1 is in, so get rid of that, get rid of that. What you're left with? You're left with 0, 2, -2, 1. Okay, then we do the same with the last one. I forgot my 1 in there. And then it's a plus, now it's a -2, I'll tidy that up obviously. Again, you're looking at the last one in this top row and getting rid of everything that's in the same row in the same column. So 0, 1, 2, 1. So your 3 2 by 2s should therefore be different. Okay, I'm just going to get rid of that. Plus. So it goes plus, minus, plus. Gets on your formula sheet. And you're basically creating 3 2 by 2 matrices. So what we're doing is that 3 is still there. And we're doing a 2 by 2 like we did before. So that times that is 1, take away. That times that, which is -2, minus 1, bracket. That times that, which is 0, take away. That times that, which is -4. Minus 2 times that times that, 0, take away. That times that, 2. So you're going from like top left to bottom right. So we're figuring it out. So 3, that's obviously 1 plus 2, which is 3, minus 1 times 4, minus 2 times -2. So this gives you 9 minus 4 plus 4, which is 9. So again, the determinant is just a number The only thing is if it's the number 0, the question might say, what does this mean? You would say that the matrix is singular, so therefore there is no matrix. There is no inverse, basically, is what that means. So if the determinant is ever 0, it means that I can't even speak. If the determinant is 0, it means that the matrix is singular, is a kind of key word, okay? But again, when I come back, we'll talk through that in more detail.